So what I want you to do for example 3 is to sketch yourself this graph in that top little right hand corner. So it says find the area of the region, y equals x squared, and the region bounded by x plus y equals 2. So x plus y equals 2 is in standard form. You could put it into y equals mx plus b form by subtracting over your x. So you get y equals negative x plus 2. What we want to do is graph them and find their points of intersection. So x squared goes through 0, 0. It goes through 1, 1, and 2, 4. That's okay, I'm just graphing.
I don't think it's a point.
You don't need it. No. Okay, and then your next points go through negative x plus 2. So 2 is your y-intercept. So it goes down 1, right 1, so it goes through. Just kidding, I didn't go up enough. There we go.
Sig, okay?
He's okay. Steve, thank you for making sure.
Yeah, he's showing his safety.
So we are finding this shaded region in here. So what's your top curve?
Right?
Yep, negative x plus 2. What's your bottom curve?
X squared.
Does it ever change? Is the top always the top, the bottom always the bottom?
No. Well, not for the shaded region. I'm trying to find it. Because the bottom
Is the
comes
top
top.
curve always the top curve? Is the bottom curve for the shaded region? Yeah.
Okay, I was going to say, because it
Yeah.
definitely
For
switches
this
up.
one?
Yeah.
What's this point of intersection here?
They just ask us to find the area. They don't really give us bounds. So it's, we get bounds and it's like names 1, 1.
Okay, so if they intersect at negative 2, 4 and they intersect at 1, 1, we're finding the area of the region where they intersect. So we're going to go from this point of intersection to that point of intersection. When you make your bound limits, what numbers am I going to use? The x values, because I'm integrating with respect to x. So I'm going to pick negative 2, positive 1. You're going to do top minus bottom dx. So antiderivative of negative x is negative 1/2 x squared. Antiderivative of 2 is 2x. Antiderivative of x squared is negative 1/3 x cubed. And we're evaluating from 1 to negative 2. So you have negative 1/2 plus 2 minus 1/3 minus anything negative squared is positive, so you get 4. 4 divided by 2 is 2, so you get negative 2. Negative times the positive gave you a negative 4, and negative 2 cubed is negative 8. But then you have the negative 1/3, so you get positive 8/3. Combine like terms. So this negative distributes through, so I'm just going to turn it to a positive and then change all my signs. So that would be a positive, positive, negative. Negative 1/3 and negative 8/3 gives you negative 9/3. Negative 9/3 is really just negative. Okay, so you have negative 3 plus 4. 1 plus 2 is 3. 3 plus 2 is 5. 5 minus a half. Yep, 4.5 or 4.5.
I don't know.
Okay, take out your calculators.
What? This one's fragrant. There was fragrant.
I'm going back this time. You want to sit up front?
Yeah, so that you can, we gotta keep me awake. He's gotta be full.
I like the first one.
Jesse has the sun.
No, I like the track.
Okay?
Okay, how hard is it to get the orange bottle?
No, Tyler didn't have anything to let me play. That's why he told it.
Alright, what I want you to do is put these two functions in your graphing calculator.
Heck yeah.
So put y1 as cosine 2x. Put y2 as x squared minus 2. Which of the two is the top?
I just plugged my calculator and it's
There we go.
I gotta fix my window.
Maybe if you turn it on and off.
My window is
Yep. The cosine function will be the top. X squared minus 2 will be the bottom. Find the area of the region enclosed by the two graphs. So that means we need to find their points of intersection. So where do they intersect? How do you find that on the calculator?
POI.
Yeah, so what? We can't say 1/2. I need like the actual like
-1, -1 would be
Second 1.15.
1.15. Remember, you need to have 3 decimal
Oh,
places.
1.153.
I'm like, any other number.
Everyone turned your X-res to 3 and it'll speed graph. I just found that out.
and I need a speed graph.
Oh, okay.
Slow.
Hit hit window, and then go where it says X-RES, so it says X-res. Put that to a 3, because that's the highest it goes. Then hit graph and watch how fast it is. Wow.
Wait, that helps so much.
It
When I
only
sit here
3
and
is
I'm
the
like,
highest.
Right, what?
holy.
This will definitely
Yeah,
break
no,
it
I
down.
know. It's yeah.
Let me see.
Oh, I didn't know
It
that.
speeds. Yeah, I found it
Yeah,
out
that's
during one of the
blessing,
tests.
not
And I was like,
a
holy crap, that's good.
Alright, so with Steve told us they intersect at 1.153. Where's their other point of intersection?
Oh, shoot.
Yeah, you need a beginning. You need a beginning and an end.
Wait, hold on. What did you
Wait.
say?
What?
They say the plus for the negative 1. I don't have a window.
I don't know which one.
Yeah.
I think
Whichever
he
one
said
you said is the
negative.
opposite.
I think he said negative. Okay, so.
Yeah, negative 1.1.
Oh, negative 1.
Yep. So it goes from
And then
negative
also
1.153 to positive 1.153.
Oh, it's symmetrical. We only have to find one.
It is symmetrical. So what I would do is say, okay, since it's bounded from the negative to the positive, I can actually integrate from 0 to the positive and double my answer. So remember, right from the graphing page, you can get the area between the two regions. However, the calculator is going to be a little bit trickier for you to do it. So what I would do is I would hit back to the home screen. Since we're doing symmetry, type the number 2. Go to map 9. Make your upper bound 0, your lower bound 0, your upper bound to 1.153. We already took the time to type these in, right? This is. So what you could do is you could hit the vars key and insert y1 and y2, especially if the functions were really, really long. So, what? Bars, and then go over to y bars and go down.
So the top 1.
That's why it's important you know which one's y1 and y2.
Home.
Always.
Ouch.
And I hit
2.1659.
I got a different number.
and I think
I got 2.1659.
Did you remember to put the 2 in front of your integral?
times 2.
2.
4.33.
Oh, you did that.
There you go. It's just so enthusiastic. What did I say? Enthusiastic.
Hey, everybody else still got the legs up? Because mine have been up the whole time and I can't do it.
That one, yeah.
No, I put it down for a little because my
Oh, you're out of the competition. You're out.
Wait, let's do it at the same time.
No,
Same chorus.
I'm losing circulation.
See when you break
I
last.
think it's
Alright.
between me and
We're doing it at the
Sarah.
same time. Okay.
I
Alright.
do that all day. I sit like this and everything.
Ready? Alright, please.
Yeah,
At the same
like one
time.
day I
It'll be
just
like
started
yours.
and
Just once.
just-
That's all I ask.
Whoa. You finished the touch, Rich?
Never again. I won't ask anymore.
Rich, when you taking the
Just once.
We need to know the results.
Honey, I'm sleeping.
Come on.
Alright, so,
We gotta know.
oh, I need a blank page, but that is in my way.
Just
Put it down.
What did you already
Alright, let's talk about the next example.
I'll run you.
So we have find the area of one of the regions, bounded by the graphs of f of x equals sin x and g of x equals cosine x. Sketch the graph and shape the region without a calculator. It's a lot of what? Oh, wow. So what's sine do? It goes through 0, 0.
I have 1.
Pi halves 1.
I 0.
And then, okay, so here's sine. Okay, how about cosine? Where's cosine start?
Yeah, number 1, yeah.
And then pi halves goes,
I wish mine was
It goes
my
through
picture's
there.
colored.
Then it goes down to there. Then it goes up there. And up to the top again. Cool. Nico.
That's right, my boy. Get it. Get it, my boy.
okay. What would be the easiest region to find the shadedness between?
Definitely.
A triangle right there.
The
Bottom.
rectangle. Yeah, the little triangle.
Okay, but the triangle here isn't a region bounded by the graphs. This would be bounded by the x-axis as well.
This rectangle.
Yeah. So it's got to go from like here to here. Because those are the only 2 points of intersection where you have one curve and the other curve all being sines and cosines. So what would this point of intersection here be? Where do the 2 graphs have the same values? What? Awesome. So this is pi fourths. What's this point of intersection going to be where they're the same again?
3 pi over 4.
Okay.
See, that's not bad. So what's your top graph?
Hey, is that right?
Top graph is.
I was just explaining.
But
And the
3
bottom
pi
graph?
over 4 comes out to 5.
Oh, wait, no, that's not right. It's 5.
Yeah, 5 pi over 4.
Nico, seriously, dude?
And I listened to you.
Hey, Nico. This is great. Nico.
They are the same without
You
points.
child.
Man, child.
Switch up colors again. So where are we going to integrate from?
From 5 over 4. Okay, just deal with it.
How loud? Go. I think it's gonna be that loud.
Okay. Antiderivative of sine is
Cosine.
negative cosine. Antiderivative of negative cosine.
Sine.
Evaluating from 5 pi over 4. We have negative cosine 5 pi over 4 minus the sine of 5 pi over 4. if we're subtracting this whole thing again with 5/4, what's that going to do to both of these? Yeah. Okay, sine of 5/4 is awesome. Cosine of 5/4 is perfect. Okay, careful. Sine of 5π/4 is in what quadrant?
Third.
The
Two.
third.
So it's negative square root of 2 over 2, but if it's negative sign, it'd be positive.
Good. So it'd be minus a minus, but it's going to turn into a positive. How about cosine? Where's cosine 5π/4? Also in third quadrant, which also makes it
Negative.
yes, positive
That's
in
fine.
the
It's
end,
crunchy.
but negative to start. So negative root 2 plus negative root 2. Root 2 plus root 2 plus root 2 plus root 2.
4 root 2 over 2, so 2 root 2. Thank you. Sorry, do you hear what they say to me?
No. So this region in here is about 2 square roots of 2. Now you have your calculators out. You could check our math if you really want to. But you don't have to. So here's the thing. We can't always integrate with top minus bottom. It's not always going to work. There's going to be times where you have to have left to right. So we're going to have to integrate at points in time from the left to the right. If we have to integrate from the left to right, or right to left, then we have to integrate with respect to y. So we're integrating up and down instead of side to side. So let's at least start this first example. Like I said, tell me what you get when that bell rings. So we have x equals 3 minus y squared, and x equals y plus 1. So you have to almost graph these backwards from what you're used to. So that means if you pick a value for y, you're getting your x coordinate. If you pick a value for x, you're getting your y coordinate. So go ahead, take a minute, and graph these two functions. Yes, the y's go by 2. The y's are by 2.
I think my niece is giving out from the pressure.
Stay strong.
Jason? Better stop that right now. What did I do? Better stop that right now.
All right. So what did we get?
I've never graphed like this before.
All right, we'll just use desktop.
Yes, dog.
Okay. So what did we get for the x value of -2 on the first graph? So if x was -2, you could solve it backwards like this. Or did you solve it with plugging in y values of 2 and -2?
I did that. I turn my graph sideways and graph like that.
Yeah, that's what I'm doing too.
Yeah, that kind of makes sense then, right?
Do that.
It looks pretty cool, actually.
Did you get this? Did you get something like this?
Yeah, pretty much exactly.
So when your y is 0,
Yeah, I just
your
did-
x is 3. All right, go to, because I know you guys want to go to these. So go to these. If you have not finished your graph, finish your graph. We will reconvene. All right, so Jason kindly graphed for us. So again, and then Sam asked the question of what would happen if you solve for y. So again, if you wanted to solve for y and plug in x's like you're used to, you have to be cautious of the fact that when you solve for a y squared, it would be plus or minus the square root, so that you have the top and bottom half of that curve. So their points of intersection over here, this point is -1, -2, and up here, this point is 2, +1. So what we have to do is, now that we have these points of intersection and we have these bounded curves.
Why is mine going that way? Shouldn't it be going the other way?
No, he's right.
Because x is already on that side. You just have to carry over the 1. You don't have to carry over x.
Okay, I see.
Yep. So there isn't a clearly defined top and bottom graph. What happens is if you were trying to do top minus bottom, here you have purple over purple. So the top minus bottom is like the positive square root and the negative square root. And then here it's red over purple, so it would have been the line over the bottom of the purple square root. So that's really messy. You'd have to make 2 integrals. You'd have to solve for your equations. Whereas if we simply talk about the fact that we can do right minus left and integrate with respect to y, now the purple graph is always to the right. The red graph is always to the left. So what I can do is I can integrate this function from the y to the y. So my y value here is -2. My y value there is 1. So I'm going to integrate from -2 to 1. And I'm going to find the areas from the rights to the lefts. So what that means is I'm going to take 3 minus y squared, because that's the purple graph. And I'm going to subtract from it the red line, which is y plus 1. The variable with which we integrate doesn't change how you integrate. All we're doing is changing how we integrate in terms of the graph. So the antiderivative of 3, instead of becoming 3x, becomes 3y. Antiderivative of y squared becomes -1/3 y cubed. Antiderivative of y becomes 1/2 y squared. We're going to distribute that negative. And then antiderivative of 1 would become 1y. We're going to distribute the negative. You can combine like terms, if you would like, before plugging in. So we could actually say that this is -1/3 y cubed minus 1/2 y squared plus 2y from 1 to -2. And you could have actually combined your like terms before you integrated as well. Yes?
Can you explain again why the red graph is the other way?
What do you mean? Like why the slope is the way the slope is, or why it's the left function?
Well, yeah. Why is it the different? Why is it just the opposite slope?
So if that's x equals y plus 1, what they're saying is if you had solved this for y, it would just have been y equals x minus 1. So you know how to graph that. You have a y-intercept of -1, slope up 1 over 1, up 1 over 1.
Okay, so just you can do that.
Mm-hmm. So these are the 2 graphs if you solve for y's and then graph them. Okay, now what we want to do is simply plug in our bounds. So you have negative 1/3, negative 1/2, positive 2, minus negative 2 cubed, again, is negative 8, but there's a negative here. So you get 8/3. Negative 2 squared is positive, but there's a negative there, so you get negative 2. And the negative times the negative gives you the negative times positive gives you that negative 4. Ironically, which I didn't do, the answer is 9/2 again, or 4.5. We end up with another 4.5 answer today. Okay. Example, your numbers don't match mine, but example 2. Find the area of the region R in the first quadrant that is bounded above by y equals the square root of x and y equals x minus 2. So again, you have to pay attention to what they say. Find the area of the region R in the first quadrant bounded above by y equals the square root of x and y equals x minus 2. So go ahead and get yourselves both of those graphs again. So again, we are bounded by the first quadrant. So we need to find that little yellow piece there and this piece here. So we're bounding it by the graphs and we're bounding it by the x-axis. So the x-axis creates a bound here, and then the red graph creates a bound there. So this is where integrating with respect to x versus integrating with respect to y would make a difference. If I integrated this with respect to y, could I pick the y lower bound to be 0 and the y upper bound to be 2? And then does that give me a right minus left, where right is always red and left is always black? We see that? So if you integrated with respect to x's, you would actually have to set up two integrals. You'd have to set up the integral from 0 to 2 with the square root of x. And then you'd have to set up the integral from 2 to 4 with the square root of x minus 2. So you can eliminate doing two integrations into one by doing right minus left. What we have to do, though, in order to do right minus left, is we have to solve both of those equations for x. So how do you get rid of a square root? Square it. So x would equal y squared. And over here, you just want to solve for x, so you add the 2. So you get x equals y plus 2. So again, now we're going to talk about integrating from y equals 0 to y equals 2. So you have the integral from 0 to 2. Your right is this line right here, so it's y plus 2, minus your left, which is the black, so it's y squared, dy. So now we just simply take our antiderivative. So you get 1/2 y squared plus 2y minus 1/3 y cubed from 0 to 2. Plugging in our points, 2 squared is 4, 4 divided by 2 is 2, 2 times 2 is 4, 2 cubed is 8. What's really nice about the y bounds, again, is it's 0. It's so nice to subtract a 0. So 2 plus 4 is 6, 6 minus 8/3. So it's 10/3, good. So much easier to integrate with respect to y than it would have been with respect to x. So it's just a recognition of right minus left versus top minus bottom.
One question.
Yeah.
So let's say that square root function was shifted over like 2 units. And
Okay.
so you had some area that you couldn't, you weren't supposed to integrate inside and then the second part too. What would you integrate with respect to then?
You would probably have to be with respect to x because of being bounded by the first quadrant.
And how would you get rid of that like bottom part?
So here's your square root, right? So that's all you changed. And then you have your line. So like it still look like that. So this, when you, remember if you go back to way when we first did integration, and you found the area under the curve, it was automatically bounded by the x-axis. So what you would have done is you would have said, okay, I'm going to integrate from -2 to whatever this point is, and it wouldn't be 2 anymore. But let's say you still had this as your bound. This area here would be from 0, and let's say they still intersected at 2. It would only be the square root function. There would be no top minus bottom, because your graph or your calculator automatically bounds the x-axis as the base.
What about that area under the x-axis now? What you have there?
It would have automatically been bounded by the x-axis if you would have integrated with respect to x. Yep. Okay. So I believe the last one, once you'd actually integrate and compare bounding with x's and bounding with y's. So what would it look like if I did the same problem, but I bounded it with x and I bounded it with y? So we have y equals 3 minus x squared. So again, we know that that's a parabola opened down and shifted up 3. Okay, and then it says it's also bounded by the line y equals -1. So these are going to hit at the points 2, -1, and -2, -1. So we're finding the area in between. Bless you.
Thank you.
So if I found the area with respect to top minus bottom, what's my top? And then my bottom would simply just be -1, right? And you'd be integrating from, good. So it becomes positive. What's 3 plus 1? 4. So really you could change this to 4 minus x squared too, so that you don't have two constants. So your antiderivative would be 4x minus 1/3 x cubed. And you're plugging in from 2 to -2. What else could I have done to make this easier? Yep, I could have doubled it, right? I could have said 2 times 4x minus 1/3 x cubed and made it from 2 to 0 because it's symmetric. So plugging in 2, you get 8, and then minus 8/3. And then I can say subtract 0 because I doubled it. So 8 minus 8/3 is?
16/3.
Perfect, 16/3. Double that.
8/3.
If I wanted to integrate with respect to y's, what's your right function and what's your left function? I'm looking at this picture. What's on the right? The right side of the parabola. What's on the left? Left side of the parabola. Think about if you transformed this equation to be in terms of x, it would become x equals y. We'll do it this way. 3 minus y. So you'd flip your x's and your y's, and then you'd have to take the square root. The minute you take the square root, you get the positive and the negative. So do you see how this would be like the positive square root and the negative square root if I were to integrate with respect to y's? What's your lower bound on the y's? Your upper bound is?
3.
So your integral would go from -1 to 3. It would be the right side minus the left side. So minus and minus would turn to a positive. Bring out the 2 so you can add them together. What would I have to do to solve this with respect to y's? I have an inside. I have to use substitution. So, do you see why knowing which function to pick makes a difference? Doing this with respect to y is much grosser. So you want to have an idea, and that's what can happen if you wanted to integrate with respect to x sometimes. It's grosser to do it with one versus the other, so it's important to be able to see the idea and the connection between the two images. Okay, I still want to start 6-1. I'm going to pause and stop, get up, move around, but don't leave my room, don't go anywhere, because we're just going to kind of